Hi. You're going to start with Miss Andrzejczyk today. Bye.
Okay, so we're going to work on our relationships matter. But first, we're going to do the quick review. So our quick review today is here at the top. And so it says, when you mix an acid, ooh, there we go, with a base, the resulting reaction is called a neutralization. Let's make sure I'm spelling this right. Neutralization. Neutralization. Okay. Reaction. This type of reaction always results in water and a salt. Okay. Water and a salt. Always, always. The presence of carbon is what makes something organic. Okay, so if it's organic, carbon makes it organic. Living things such as trees, other plants and animals are all organic. Okay. This also are other things that are made from them. Okay, so if they were once living, they are still organic. Non-living things such as like rocks, water, and salt are all considered inorganic. The in is meaning not, inorganic. Okay, so that is our quick review. I'm going to turn it over to Ms. Harris to do our notes.
Okay, we did that fast enough. Don't even have to pause. All right, I'm clearing that. So if you need it, pause it right now because I'm erasing it. And here we go. So last week, and it was last week, and this is all frozen. Gotta love technology. Last week, you learned when you mix an acid with a base that a special type of reaction occurs called a neutralization reaction. Now, that's like the third time we've talked about that in 5 minutes. So maybe test question alert, right? That might be something that you need to know. Okay. When you take that acid and base, it doesn't matter. It could be a burn your face off acid and a burn your face off base. But when the two of them come together and neutralize each other, they are neutralized. And we get a salt, and it could be a number of different types of salt. And we talked about those last week, and water. So what exactly is an acid? An acid is any substance that produces hydrogen ions. And we write that as H, the symbol for hydrogen, and then plus. And what that means is there's no electron. That atom of hydrogen has one proton, no electron, and therefore it has a positive charge. So it's a hydrogen ion. It's a single hydrogen atom that has only one proton and no electrons. So it has that positive charge. All of the acids that you're going to possibly think of, when you dissolve them in water, they create hydrogen ions. So all of the acids that we are going to talk about today contain hydrogen. And what is a hydrogen ion? Well, let's write out that definition. A hydrogen ion. And how do we write that? H plus is an atom of hydrogen that has lost an electron. So it has no electron, or one little electron that it had is gone. So for example, when we have hydrochloric acid, now we've all heard of hydrochloric acid. That's the one that when you watch a movie and the bad guy, they've got to get rid of the body and they put his fingers in hydrochloric acid to burn off his fingerprints and all that jazz. We've heard, but movies use it all the time. And it really is that bad. Hydrochloric acid is incredibly, incredibly caustic. But the thing is, hydrochloric acid can be broken apart easily by water. Drip, drip, drip it into water and it just breaks apart. So if I take my hydrochloric acid and I drip it into some water, it's going to break up into positively charged hydrogen ions and negatively charged chlorine ions. And those hydrogen and chlorine ions would be floating around in the water. If the water all evaporated away, those positives and negatives would snap together like magnets, and we'd end up back with hydrochloric acid again. So you can't think that like, oh, I watered it down and just sit it in a corner. No, you got to water it down and then dump it out and do all kinds of jazz. All right, hit pause if you need to write stuff down. I'm clearing it. If we were in class, I'd say going once, going twice. Now, if I used a different acid than hydrochloric acid, I would get a different negative ion. I wouldn't have chlorine. I'd have something else because it was a different acid. But it's always going to be hydrogen as the positive ion. So those hydrogen ions are the key to the reaction of bases. So how strong are the hydrogen ions? That's how strong of an acid it is. So hydrochloric acid, we've already know that one. That one's HCl. Whoop, 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 whoop. Test question alert. I want you to know the chemical formula for hydrochloric acid. Nitric acid, that one I need. That one I memorized. HNO3. So I should though, because I know that NO3 is nitrate. Anyway, hydrogen and then a nitrate ion. So we have our positive hydrogen ion and our negative nitrate ion. Sulfuric acid, I bet it's a sulfate. Is it SO4? H2SO4? Am I right? Ha-ha! Maybe I've been teaching this for long enough. So sulfuric acid, again, we've got our hydrogen, positive hydrogen ion, and then a sulfide ion, which attracts to it. And then acetic acid. Acetic acid is vitamin C. That's what acetic acid is. And it's pretty complicated. It's got one hydrogen ion that has carbon bonded to it. So that's one separate ion. And then separately, there's a hydroxide, or not hydroxide, that would be OH. This one it's got a different name. But the point is you've got two separate hydrogens there. And yes, it's all part of one formula for acetic acid. All right, so those are our acids. What about a base? A base is any substance that produces hydroxide ions. And we write that as OH, and then it's negative in water. So the bases that we're going to talk about today are all something, something hydroxide, something, something hydroxide. Excuse me. Because that is the key to bases, is those hydroxides. Now, how in the world are you going to remember this? It's really dumb, okay? It's really, really dumb, but it works. You know how the lyrics to every boy band song ever are, oh, baby, baby, oh, don't leave me, girl. Ooh, oh, baby, baby, oh, baby, baby, oh, right? Oh. How do you spell that? O-H. Okay, right? So this is how I remember it. I remember O equals boy bands, right? And boy bands, I hate boy bands. So that's negative. So there we go. OH, B for base, and then it's negative. Because how negative of an attitude is it to have for me to say, oh, I just hate boy bands, and just automatically say it? It's pretty negative. So there you go. O, boy bands, base, negative. And so then all you got to do is just remember that the other one is everything else when you're choosing your answers. So we know that acid is hydrogen plus, and base is OH negative. Test question alert. Woo. Okay, moving right along. So what is a hydroxide ion? A hydroxide ion, and we write that OH negative, is a polyatomic ion. Polyatomic, meaning many atoms. It just means it has more than one atom. So instead of just being C, it's OH, right? It's both things. So it's a polyatomic ion, and it does have a negative charge, and you can probably guess what elements it's made out of: oxygen and hydrogen, because they didn't change the symbols. When bases dissolve in water, we get positive ions of some other kind, and then we get these negative hydroxide ions. So, for example, sodium hydroxide, NaOH, burn your face off base, like really caustic base. When you drop that into the water, drip, 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 we get positive sodium ions and negative hydroxide ions. and they separate out from each other. They float away in the water. But just like the acid, if you were to let the water evaporate, they would snap back together because we would end up with positively charged sodium ions and negatively charged hydroxide ions. But just like magnets, they're going to snap together. They'll dissolve apart in water, but if the water that's between them evaporates away, they're snapped back together again. If we use a different base, we're going to get a different positive ion. If it was KOH, if it was potassium hydroxide, we would have potassium as our positive ion that was formed. But since it's sodium hydroxide, we're going to make sodium as our positive. So, but no matter what, we're going to get our negative hydroxide ions. And those hydroxide ions are the key to why bases react the way they do. Why do they make your face want to melt off? Why do they neutralize acids? It's because we've got that hydrogen positive balancing out with that OH negative. And when they snap together, we get H2O. What's that make? Think about it. All right, so sodium hydroxide. Test question alert. Whoop, 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 whoop. This is one I want you to know. No, but not right now. I need you to know now. I need you to know sodium hydroxide, NaOH. So you got to know NaCl, sodium chloride, and you got to know NaO, NaOH, sodium hydroxide. Potassium hydroxide is just KOH. Calcium hydroxide is Ca2OH because you actually have to have two, right? Or is it the other way around? It's one way or the other. Yep, it's the other way around. That's all right. I know you needed two of them. Well, as I was thinking about it, I was like, wait a minute, that doesn't make sense because it only has one and the calcium has two. Anyway, calcium has a charge of 2, so that means it needs 2 of the hydroxide particles to balance it out and make a formula. So CaOH2, and then magnesium is in the same family as calcium, so it's going to be written the same way, MgOH2. And no, y'all don't have to know the rules for how these go together. It's a chemistry teacher, I do, but y'all are good. All right, so I'm going to pause there for a second because I want to talk to you about what the world used to be like. All right, so, well, first I want to show you something. So we know that we've got, so do I have any empty space here at all? Yeah, down here. All right, so, well, but that's no good either. I'll do it here. All right, so we've got hydrochloric acid, which we know is a burn your face off acid. And then we've got sodium hydroxide, which is a burn your face off base. And these two come together, neutralize each other, right? Well, look what happens. I've got Na and Cl. And that, of course, makes sodium chloride, salt, table salt. And then I've got H, and O, H2O. So burn your face off acid, most caustic substance on the planet. Burn your face off base, next most caustic substance on the planet. Put the two of them together and we end up with the two most common compounds on the planet, water and salt. What are the two most common compounds on the planet? Water and salt. So what must the earth have been like, a couple 100 million years ago? Right, burn your face off. Burn your face off acids, burn your face off bases. Not a fun place to be. It's just something, something you should consider. All right, so acids and bases. You have heard of acids and bases before. You're talking about getting your shampoo needs to be pH balanced. And these days, having alkaline water is a big deal. Having water that's basic. You don't want water that's too acidic, and you don't want water that's neutral, like normal water that's just a 7. No, you want something that's got a pH of 8 or 9 because basic water, alkaline water is the thing. I don't know why. Does it have health benefits? It might. I don't know, but it's the craze right now. So let's talk about it. Acids and bases may be strong or weak. So you can have a weak acid, you can have a weak base, you can have a strong acid or a strong base. All of that depends on the kind of ions that it produces in the water. So if it produces a whole lot of ions, it's a strong base. If it produces not many ions, or acid. If it produces not many ions, it's weak. That's just the way it is. So with a strong acid, most of the molecules react, so we get more hydrogen ions, and that makes it a stronger acid. With a weak acid, we get fewer molecules, so we get fewer hydrogen ions. With a strong base, most of them react, so we get more hydroxide ions. And with a weak base, fewer molecules react, so we get less hydroxide ions. All right, I'm going to clear it and scroll it up so we can look at this pH chart. Going once, twice. Oh, wait, there's no one in here. All right, so we have this lovely pH chart here, and these are not the ones. There we go. I always add in some every year. For some reason here, can you add them onto that one? For some reason that's why this second one's in here. I bet you money so that this would be here. All right, so I add in some stuff every year, and I want you to add it in as well if you can. I understand that if you're doing this electronically, you probably can't, but at least think about it in your little noggin. So 0 is a burn your face off. And these are acids on this side. And then 14 over here is a burn your face off. But those are bases. Then here is neutral. Vinegar. What happens when you mix vinegar and baking soda? Right? You get a chemical reaction. It's a neutralization reaction. And there are some other things going on there because baking soda and vinegar are both more complicated than just pure acid and pure base. But you are creating water and salt. So vinegar is actually kind of close to tomato juice. So we're going to put vinegar in there under tomato juice. And then for some reason, water isn't in here right at 7. So pure water should be a pH of 7. Then soap and shampoo fits in here. Around where baking soda is. Soap and shampoo tend to be a little basic. Bleach is basic. I did. So bleach is usually somewhere around here in a 3. Bases tend to be a little slippery. Have you ever felt bleach? It's kind of slimy. And that's what soap is, kind of slimy. And it's just one of the features of bases is that they're kind of slimy. Drain cleaner, like Drano or whatever, is usually around an 11. Okay, so I would want you to add all those things in. Now, what do you need to know? Acids have a pH of, well, let's look at our thing, 0 to 6. So if it has a pH between 0 and 6, it's an acid. Bases have a pH of 8 to 14. And neutral substances have a pH of 7. So now I'm going to leave that up there. I want you to fill in this part. So pause, fill in that part. Name some common things that are acidic, some things that are basic, and some things that are neutral. I want you to put 2 in each line and then unpause and check your answers. I know you paused it, didn't you? You did. You got your lines all filled in. You paused it. You're all set. So now I'm going to give you the answers. So things that are acidic. Well, anything that we wrote over here. So gastric juices means your stomach acid. So stomach acid could be something that you wrote. You could have written lemon juice. You could have written cola. You could have written vinegar or tomato juice. Oranges, citric acid, all of those would count. All right, bases are all the things that are over here. So you could have written seawater, shampoo, baking soda, Drano, bleach. And then, of course, we've got hydrochloric acid and sodium hydroxide. Now, the thing is, hydrochloric acid and sodium hydroxide can go pretty much anywhere between 3 and 0 and between 11 and 14. It depends on how strong you make it. And then neutral, saliva, water, blood, and tears. And all of those things are mostly water. So that's why they are neutral. Okay, I'm done with my part. I'm going to let Ms. Andrzejczyk come in to talk to you about density. I'm going to clear this for you, though.
Okay, guys, density. So here we go. All right. So blast from the past to start with. This should be a review. Okay, so this should be a review, but if it's not, let's go over it and make sure you know it. All right, the amount of matter something has inside is mass. Okay, so the amount of matter that something has is mass. The amount of space that something takes up is volume. All right, so to then determine density, the amount of matter packed into something relative to its size, you have to know the mass and the volume. Okay, so that density formula is, so we have density is mass divided by volume. Okay, so mass divided by volume. And there's different ways that you can write this, including this special character
Rho.
That's called a rho. Okay, and I believe it is Greek. Okay, so it's just a fancy letter that's Greek. It means the same thing, density. All right, let's go on to the next thing. We are going to calculate the density of some of these common objects. All right, so you get your calculator if you need it.
Okay. We can pull up a calculator on the screen so that you can do it. Here, I'll pause this.
All right, guys, now that you have your calculator, let's go ahead and get some math done here. Did you know that you're going to do math and science all the time? Here we go. So, pencil, 3 grams for the mass, 15 centimeters cubed for the volume. So we're going to take density equals 3 divided by 15. So let's go to our calculator and see what that's going to be. We have 3, oops, I have to put my pen down, 3, why won't it do 3? Pause. Okay, sorry, technical error. 3 divided by 15. And that's going to give us our answer, 0.2. All right, so we're going to go back to our notes. And we have 0.2 grams over centimeters cubed. Okay, because we got to carry on our information there. So our number is going to be 2 because our density, the least dense object with a 1 and the most dense with a 5. Okay, and we'll put those in order in just a minute. I'll put that one there and then we'll come back to it. Our next one, textbook, 1 kilogram and 2,000 centimeters cubed. Here we go. Let's go to our calculator. And we have 1 kilogram divided by 2,000 centimeters cubed. That's going to equal 0.005. We need to move that decimal point so that we have grams instead of kilograms. So we're going to move that decimal point over. And our answer is 0.5 grams. So we moved our decimal point over centimeters cubed. Okay. All right, let's look at our next one. Lead ball bearing. Okay. We have 200 grams, so we've started with our right, 200 grams divided by 10 centimeters cubed. There we go. 200 grams divided by 10 centimeters cubed. That is going to equal 20. Let's go back to our notes. So that's going to be 20 grams per centimeters cubed. All right. Next up, inflated balloon. Inflated balloon. So we have 0.01 grams divided by 300. 0.01 grams divided by 300 centimeters cubed equals. All right. We need to write small here. We've got 0.0000. There's 4 zeros there. 3 grams over centimeters cubed. Whew. All right. Last one, rocks. Okay, so rocks, their mass is 25 grams. Their volume is 5 centimeters cubed. Let's do the math. 25 divided by 5 equals 5. That's one you probably knew already. Okay. So we're going to have 5 Nice even number. Grams over centimeters cubed. Okay, now let's put them in order. So our inflated balloon is going to be our least dense. Then we have our pencil. Then we have our textbook. And then we have a rock. And then, not surprising, lead is very dense. So we have our lead ball bearing as our most dense item in our list. Okay, go ahead and pause if you need a moment to finish that up. Make sure you did the math along with me. I'm going to clear and move up the board. Okay, almost done. So the size of the object doesn't matter as much as how much matter is packed inside of it. Okay, so you can have a lot of stuff in a small amount of space. It's very dense. So the more matter,
Like the genie in Aladdin.
yeah, it's kind of like the genie in Aladdin, right? The more matter that's packed inside, the more dense the object is. An object that is very large, but is mostly empty space, like our balloon, will be less dense than a very small object that is packed full of matter. Okay? So an object that has high density will be heavy for its size. But an object that has low density will be light for its size. Maybe go around your house and try it out. Okay?
The thing I think of the most when I'm thinking about density is the difference between a piece of marble and a piece of styrofoam. They could both be the exact same color, size, shape, sitting in my hand, but I'm going to easily be able to tell which one's more dense because that piece of marble is going to feel really heavy in my hand, and that piece of styrofoam is going to feel really light. Same size, same shape, but completely different weights because one has more matter packed into that same amount of space. Right? Right. Okay. Thank you guys. Bye.